Hi everyone. Today our topic is physics notes on motion. Scalar quantities. Physical quantities which have magnitude and no direction are called scalar quantities. In these physical quantities, they are independent of direction, only magnitude. Okay. Examples are mass, speed, volume, work, time, power, energy, etc. Okay. Vector quantities. Physical quantities which have magnitude and direction both, okay, and also obey triangle law are called vector quantities. Example: displacement, velocity, acceleration, force, momentum, torque, etc. Electric current also a direction, but it is a scalar quantities. Why? It does not obey triangle law. So vector quantities obey triangle law. Remember that, okay? Distance. Distance is the actual path traveled by a body in a given period of time. But a displacement is the shortest distance. The change in the position of the object in a given period of time. That is displacement. Distance is a scalar quantity, but displacement is a vector quantity. Both having same unit meter. Okay. Displacement may be positive, negative, or zero, but distance always positive. Okay. Speed. Speed is equal to distance by time. It is a distance traveled by the moving object in unit time interval is called speed, and it's a scalar quantity. Its SI unit is meter per second. Okay, unit is meter per second. The speed of an object at any instant is called instantaneous speed. Okay. Next, velocity. Velocity is equal to displacement by time. So velocity of a moving object is defined as the displacement of the object in unit time interval. It is a vector quantity. SI unit also meter per second. Okay. If a body undergoes equal displacement equal interval of time, then it is called uniform velocity. But if a body undergoes unequal displacement in equal interval of time, then it is called variable velocity or non-uniform velocity. Okay. Relative velocity. Suppose two objects, their velocity is v1 and v2 respectively. If they are traveling in opposite direction, then relative velocity will be v1 plus v2. Just to add the velocities. Okay. But if they travel in same direction, then relative velocity will be v1 minus v2. That's the relative velocity. Acceleration. Acceleration is of an object is defined as the rate of change of velocity of the object. Simply rate of change of velocity or difference in the velocities divided by time. Final velocity minus initial velocity divided by time. It is a vector quantity. SI unit is meter per second square. If velocity decreases with time, then acceleration is negative and is called retardation. If acceleration does not change with time, then it is called constant acceleration. Next is some of the equations that are connecting final velocity, initial velocity, time, acceleration and distance. V equal to u plus at. S equal to ut plus half at square. V square equal to u square plus 2as. Here v is the final velocity, u is the initial velocity, t is time interval, a is acceleration and s is distance travelled. Okay, v equal to u plus at, s equal to ut plus half at square, v square equal to u square plus 2as. Angular displacement and velocity. Before studying that, we have to study circular motion. The motion of an object along a circular path is called circular motion. So next, angular displacement. The angle subtended at the center of a circle by a body moving along the circumference of the circle is called angular displacement of that body. Okay. Its unit is radian. So angular displacement is equal to length of arc divided by radius of the circle. Next, angular velocity. Angular velocity is the time rate of change of angular displacement. That is angular velocity. Force. Force is that external cause which when acts on a body change or try to change the initial state of the body. Suppose if we apply a force to a body, then initial state of the body will change. That is force. Okay. Force is equal to mass into acceleration. F is equal to ma. M is the mass of the object in kg, kilogram, and A is the acceleration in meter per second square. SI unit of force is Newton and is denoted in capital N. Then a body is said to be in equilibrium if the sum of all the forces act on the body is equal to 0. Understand? Then nuclear force is the strongest force and gravitational force is weakest force. Next is Newton's laws of motion. There are 3 laws. Newton's first law. If no external force acts on a body, then it remains in same state of rest or motion, that is in its present state. Inertia of rest. What is inertia? Inertia is the property of a body by virtue of which it opposes any changes in its state of rest or in uniform motion. For example, when a bus or train at rest start to move suddenly, the passenger sitting it feels a jerk in backward direction due to inertia of rest. That is about first law. Then the inertia of motion. For example, when a running bus or train stops suddenly, the passenger sitting in it jerk in the forward direction due to the inertia of motion. So understand the difference between inertia of motion and the inertia of rest. Okay. Then Newton's second laws of motion. The rate of change of momentum of a body is directly proportional to the applied force on the body and take place in the direction of the force. Okay. So F is equal to ma, where F is equal to force applied, m is the mass and a is the acceleration. Is force. Okay. That is second law. Newton's third law of motion. To every action there is an equal and opposite reaction. Examples of third law: recoil of gun, motion of rocket. These are the two main examples of Newton's third law. Okay. Centripetal force. When a body is in a circular motion, a force always acts on the body towards the center of the circular path. This force is called centripetal force. Centripetal force is equal to mv square by r. F is equal to mv square by r, where F is the centripetal force, m is the mass of the body, v is the velocity, uniform speed, where r and r is the radius, circular path of radius. An example, roads are banked at turns to provide required centripetal force for taking a turn. This is the main example. Next is centrifugal force. Centrifugal force is such a pseudo force and it is equal and opposite to the centripetal force. Okay. Then momentum. Momentum is the property of a moving body and it is defined as the product of mass and velocity of the body. Okay. So momentum is equal to mass into velocity. P is equal to mv, where P is the momentum, m is the mass of the body, v is the velocity of the body, and its unit is kilogram meter per second. Next is impulse. When a large force acts on a body for a very small time, then force is called impulsive force. So impulse is defined as the product of force and time. Impulse is equal to force into time. Okay, it is a vector quantity and its direction is the direction of the force. SI unit is Newton second. Okay, NS, Newton second. Then friction. It is the force which acts on a body when two bodies are in contact and one tries to move over other. Okay, that is friction. Types of friction: static friction, limiting friction, kinetic friction, sliding friction, and rolling friction. Friction is necessary for walking and to apply brakes in vehicle. And friction can be reduced by applying the polishing or applying any lubricants. That's all.